Welcome everyone. I don't know how many people we are expecting, but anyway, I
There are
think
4 people in SIS, and 3 of them are here, so that's good
okay,
score.
great. So, for those of you who don't know us, I'm Dan, and Rudolf is the co-organizer of this course. And later during the semester, we may have one or two invited talks by Andrei Boyar about machine translation as well. Uh, a few organizational items in the beginning. As you noticed, we are recording this session to make sure it is available later for later viewing. That's actually a regulation ordered by the faculty. So while you are welcome to interrupt us and ask questions even during the presentation, by doing so, you agree to be part of the recording. If you don't want to be recorded, then we can do any question answers at the end of the session when we will stop recording. If you want to ask about something specific during the talk, you can also write your question down in the chat window. But please be advised that while I'll be sharing my slides, I will not see whatever happens in the chat window. So I will not react immediately. So please also note down the location in the slides to which your question pertains, because later on we will not know where exactly this happened. Otherwise, mostly these classes will be organized into halves, where in the first half I will talk with slides, some introduction to the that day's topic, and in the second half, Rudolf will have a more hands-on session with practical tools and data, and that will typically spill over to your homework, which will be also counted towards the credits for this course. So that part will be introduced by Rudolf later when we come to it. And I will now try to share my screen and start with the talk for today. So you should now see the title page of my slides. If not, then please shout. So this is this course is called Multilingual Natural Language Processing. And right in the beginning, we wanted to, in order to avoid possible confusion, to position ourselves to a slightly similarly named course, which is called Variability of Languages in Time and Space, which is taught by these three nice ladies. And I think it's in the winter semester. So this year it's over already. But there's no formal prerequisites relation between these two courses one way or the other, but they are intended to be in some sense complementary. So it might be advantage for you to attend both, either before or later, because they will give you different angles of multilinguality in the word. So from a very remote view, the variability course, so the other one is more linguistically oriented, and there is less computation, if any, while what we do here will be more practically oriented. There will be more concrete tools or more focus on technical aspects of multilinguality, and I would say less linguistics, even though this introductory class today is actually an exception. We will be talking more about directly about languages and linguistics today than later. So another introductory thing I wanted to show is some sort of vague motivation, or why would we want to do multilingual processing. Uh, Essentially, it's the important the important motivation here is that whatever we do in natural language processing should be applicable to multiple languages. Uh, Rarely it's useful if it just depends on properties and data of one particular language. Uh, there has been a huge shift towards multilinguality over the past 2 or 3 decades, and to find out what actually happened in the community when we started this course a couple of years ago, I wanted to do something like a study of the overall multilinguality in the NLP research by looking at conference papers. I didn't want to invest too much time to it, so it's really incomplete. It's just to give you some glimpse of the change that has happened. So I just looked at the proceedings of the main computational linguistics conference, the ACL, and I only searched for papers that had parsing in their titles. So that's like focusing on one particular subtask of natural language processing, even though obviously a paper could be about parsing without having the word parsing in the title. And then whatever I got, I went through the papers and try to find out what language they actually work with. And I did 3 such probes into ACL proceedings, roughly 10 years apart. So I started with ACL and calling 1998, which happened in Montreal, Canada. And there were just 9 papers with parsing. And it was possible to identify 3 languages that the papers were dealing with. English, Spanish, and German, where both Spanish and German were just once represented there, and English was 4 times there. And there were 4 papers that did not do any evaluation or didn't say what language they work with. So they were just like they were showing some algorithms for syntactic parsing, but they were not even showing evaluation on a particular data set. And one important thing here is that in those days, people often were presenting research on language where they implicitly assumed that everyone will understand they are working with English. So why would even anyone work with anything else? So from our European perspective, this might seem crazy, but in those days, there wasn't much data available in other languages anyway, so it wasn't so easy to evaluate on anything else. Later on, in 2007, the ACL took place in Prague, and there were 12 papers that had parsing in their title, and there were already 13 languages involved. Again, English was prevailing, but there was 3 times German as well, and there were like Arabic, Czech, Danish, Basque, Japanese, Dutch, Portuguese, Slovene, Swedish, and Chinese, the other languages. And it was also a bit disproportional because there were papers which work with just one language, but the maximum was 8 languages in one paper. So we can see that there were already experiments that people did with multiple languages and try to show that their approach works across languages or for many languages. So the average was already approaching 2 languages per paper. So if that was really not average, but the standard, then everyone would try to show that at least there are 2 languages where their approach does something meaningful. Now, ACL 2016 in Berlin. There were already 24 papers and 24 languages involved, and the maximum was 18 languages per paper. So you can see the clear shift towards multilinguality in parsing, but you would see similar shift in many other tasks of natural language processing. Not in all of them, because still there are subtasks where we don't have much data for other languages than English, but obviously the trend is there. The other question is what the language families are and whether it teaches you a lot if you just switch from English to German, while there are many other languages from other families, but we will get to that in a few minutes. So again, to recapitalize, the trend is clear here in these four gradually improving or widening points of multilinguality. Initially, uh, the standard was that a paper would not even evaluate anything on data because it was in the 1990s and not everyone had enough computational power or data to process anything. And then evaluation was on English, which usually, at least in parsing, meant the pen tree bank, and usually just one language per paper. And even later, there was evaluation on multiple languages, but again, because of what data was available for evaluation, it was still skewed towards a few languages or a few families. Normally, you would see many Indo-European languages, uh, and if it's a bit wider, then you would see so-called big languages of Europe and Asia. So it would possibly include some Chinese, Arabic, or Japanese, which are other language families. In Europe, you would see possibly Uralic languages, mostly Finnish, sometimes Hungarian. You might see Turkic languages, but it is still not enough, because even if this is already an interesting sample of languages and of what you can find for language uh, mechanisms and phenomena in those families, it is still very underrepresented when viewed from the global perspective. So the focus has been shifting more and more towards resource poor languages, which is not necessarily small languages. Many of them are small, meaning like there are few speakers of those languages, but not all of them. So there are some large languages, even Indo-European languages, like Indian languages with tens of millions of speakers, which don't have much data. And then there are whole families of languages like Austronesian, that means languages like Indonesian and Tagalog in the Philippines, that have hundreds of millions of speakers and very little representation in the techniques and data sets for natural language processing. Not even to speak about the Niger Congo family in Africa, where we also have hundreds of millions of speakers, but even much less representation for NLP. And saying that they are different families means that the languages behave quite differently from what we normally see in the big languages of Europe. So that also means that not necessarily you may be able to apply the same methods everywhere. So that's why it's worth studying how those languages work and how possibly our algorithms work for those languages. Last but not least, if the language is resource poor, then we will also have to investigate techniques how to port existing algorithms to those languages, even if we don't have the data. So how can we leverage data, the models that we have for other languages, and possibly use them at least as approximation for the resource poor languages? So that will be a large part of what we will be telling you in this course, in this semester. Now, in this introductory presentation, one thing that we may want to ask right in the beginning is actually how many languages are there? And if you see such sort of introduction in a natural language processing paper, is quite likely that you will see the figure around 7,000, which is frequently cited, that comes from the ethnologue database, which is at least partially available on the web, which is provided by the SIL Foundation. Uh, this figure has also been criticized by some linguists as overestimated, because it depends on what your motivation is. SIL's aim was translating the Bible into as many languages as possible. So maybe if they have more languages, then they can claim that they will have more translations. At least that was the main point of the criticism. Uh, there's always the inherent question: where is the boundary between a language and a dialect? So, and there is a famous saying that language is a dialect which has a government and an army with it. So that's it's like there's no clear answer whether something is language or a dialect, but anyway, the figure will be somewhere in the order of thousands. So maybe some more realistic estimate might be something like over 4,000. But in any case, many of those languages are highly endangered. So it is quite likely that many of them will disappear within 100 years or so. But there are still hundreds of languages that fall uh, into the category which I mentioned previously, that they have enough speakers and we don't know enough about them when we design our language modeling tools. Related to the number of languages and their categorization is language codes. This is high technical stuff, but we need to be able to somehow refer to the languages, if only because their names are not standardized. And sometimes the name of the language, there might be two names like Slovene and Slovak, which look almost the same but refer to two different languages. And then there might be two completely different names, or more than two, that refer to the same language actually, or to the same set of dialects. So there have been attempts to standardize the codes that will be used in information processing to refer to languages. None of them is perfect, so often you will find people, speakers of particular languages or scholars of particular dialects, that they are not happy with the categorization, but it's still better than not having anything. So we have to pick some sort of categorization when we are working with less known or less widely known languages. And the most widely used categorization is probably the ISO 639 standard, which has several versions or several substandards. Uh, uh, 6391 is the two-letter code, which only cover major languages. And then there are two versions of, or three versions of three-letter codes. So mostly I would advise you to stick with ISO 639.3, which is reasonably, it has high coverage. It covers many of those languages. I would say probably they cover all the languages from the ethnologue, because if no code existed before for that language, then they actually took the code from ethnologue. So there should be something like 7,000 of these codes. And some special, like MUL for multiple languages in a data set. If you have a data set where there are multiple languages and you don't know which ones they are, then you can use this code. You can use MIS for languages without code, or you can even, there is some part of that code space available for your own definition. I think Q, starting with Q, then you can define your own code for your own purposes. So some people, some tools will always use this code space to refer to languages. Then in some other environments, there is a recommendation to use the 2-letter code if it's available, and otherwise use the 3-letter code for other languages. So for instance, in Wikipedia, if you look at the various language mutations, you will find out that they use this approach. And the final thing that I want to mention here is the glottolog codes, which you will also find them in Wikipedia when you look for languages, and they have much larger space of codes for both languages and their dialects, so they can categorize pretty much everything that has been described in the linguistic literature. Now, the main topic that we want to tackle today, and that you also will be playing with later in the practical session, is the Word Atlas of Language Structures, or just WALS. And that is one of the many tools that are online where you can search for languages. And in this case, you can not only learn that the language exists and that it's spoken in that and that country and that it belongs to that and that family, but you can also learn about some properties of the language based on reference grammars that people have written and nicely categorized into many different features. And you can also visualize the features like this on this slide. So you can see the geographical distribution of various features. So in this case, as an example, I took the feature of gender, or more specifically number of genders. So it means there's a feature of gender like masculine, feminine, and neuter in the Slavic languages or many Indo-European languages as well. And because it's a grammatical feature, it means that the gender is somehow important in the grammar. It doesn't mean that the language can describe uh, animals or persons that are male or female. That's not important. Important is if the grammar reflects this somehow. And in the case of gender, it actually does not necessarily mean that there is always correlation between biological sex and the grammatical gender. So sometimes there will be genders for inanimate objects that will still use the masculine or feminine grammatical behavior. And now linguists have been studying this, so they have found that there are languages which don't have any such category at all. Those are the white circles here. So we can see that there is some geographical pattern into it. Many Australian languages don't have gender, many American Indian languages don't have it, and so on. There are languages which distinguish 2 genders, those are the yellow circles here, and 3 genders, those are the orange circles here. So you can see that in Europe, this is the, and in Indo-European space, this is the more frequent pattern. And then there are languages, mostly in Africa, that have many genders. And in those cases, it's usually no longer called a gender, but rather a noun class. So they classify nouns into many semantically distinguished classes that behave differently in the grammar. So that's why they are like gender, but there are many of them. So you can see there are some patterns, and you could see the same thing for other features like grammatical number or various tenses or word order and so on. So you can see this on the map, and you can see also a table with the feature values. Now the question is this useful for natural language processing? And the answer is definitely yes. We should be able to find out whether 2 languages behave similarly in some aspects, because that could help us understand whether some particular type of modeling in natural language processing will, if it works for language A, whether it's likely to work for language B as well. And if it doesn't work, whether it might be linguistics that's the reason. There could be other reasons, of course. The reason could be that your data for the other language is noisy or too small or whatever. But if it looks like there are no other technical reasons, then you may ask yourself whether the similarity of the languages or dissimilarity may be responsible for that. So that's why I highlighted similar languages here. That's something we need to be able to estimate somehow. And WALS is actually useful not only because you can view it online and like manually assess whether two languages are similar or not, but you can actually download it as a database, and then you can curate the database. You can process it with your scripts. You can do whatever you want. So there are currently 192 features, which in WALS they are called chapters. The chapter always describes the phenomenon in the language and tells you what the values are and how they are distributed and so on. Not necessarily all of the features will be helpful for everything. So since we, at least in this course, will be mostly playing with text data, we might not be as much interested in features that describe phonology of the language. Of course, if we were processing speech data, which is also an important part of natural language processing, then phonology might be much more interesting for us. Features 129 to 138 are about lexicon. Again, some of them might be rather of uh, linguistic curiosity. Like there is one feature which tells you whether the word for tea in that language is likely to be related to tea or related to chai. So that's really a single feature that doesn't seem to help much with natural language processing, but there are others that might be more useful, like how the numeral system is organized. So even if the features are, you think the features might be useful, they may not all of them have the same weight. So that's just a word of warning that you want to be aware of what the features are, not just take them as another huge data set which you will feed into a neural network and no longer query what it actually means. One other thing that you have to know, and which is unfortunate, is that some features, even if they are useful, may be sparsely annotated. So it's not that for every feature that is defined in WALS, you will find values for all the languages of the world. Sometimes just they didn't find the relevant information in the reference grammars, or they didn't find it useful to like filling the same feature for all the languages in the family because they said, okay, we have two representatives of that family and that's enough. And sometimes it just seems that the feature was added later and they didn't have manpower to edit for all the languages. So one feature that I would find quite useful is the writing system, whether they use the Arabic script or Cyrillic or Latin alphabet, but it's only indicated for 5 languages, or at least it was when I was preparing these slides. Maybe it improved in the meantime. So if we again look at the gender in WALS to illustrate this, it's a lexical category of nouns, as I said, but it also appears, if it's important for the grammar, then it means that it appears somewhere else to show agreement with the nouns. So it could be pronouns. If you have in English to select between he, she, and it, that means that English has gender, although English doesn't have the gender category anywhere else. So in English, it's only important for pronouns. But in other languages like Czech, you may need it also for suffixes of adjectives or determiners where you have to show agreement with the nouns they modify, or in verbal inflection or elsewhere. So that's one thing. It's different where it is important and where it is less important. So you've seen English on that map, and you've seen some Slavic languages there, but I would argue that it's probably much more important for many tasks in the Slavic languages than in English to know the gender. Now, the data may also not be spread evenly. So there is Ukrainian and Russian. It says they have three genders, even though some people might claim that the genders would be actually there would be four genders, because masculine animate and masculine inanimate behave differently in most Slavic languages. And if you want to find out where Czech and Slovak fall there and whether they have the same value as Ukrainian and Russian or not, you will not find them at all, even though they actually have the same values, but you will not see it from WALS. Now, one more thing that I wanted to say, as much as you want to be aware of what the features mean, you also want to be aware of what the values mean, because if you look at language similarity, I would claim that the similarity between 2 and 4 genders is higher than between 0 and 2. So it's not just mathematics, but if a language doesn't have genders at all, then it's more important information than whether it has 2, 3, or 4 of them. So to briefly summarize this WALS, there are word order features. Those are one of those that I believe might be important for language similarity whenever you do syntactic parsing or something, even with morphology. There are verbal person marking features, 4 of them. Locus of marking, that means whether you mark verbal arguments on the verb or on the arguments. Case features, and various endemic function words like copula, question particles, and so on. So those would be my pick for you, the features that are probably worth looking at more than the others. Now, that's almost all I wanted to say. My final slides is just to draw your attention to something that happened last year. Last year, this slide actually said, join us, we want to participate in a shared task. So it's now over, but the shared task organized as a part of a workshop at a conference was focused on prediction of typological features in the languages in WALS that are missing some features, based on the features that are available there. So it models correlation between features. So something like, if you see that the language has a verb final word order, then it's also likely to have postpositions and not prepositions, for instance. So things like that are to some degree predictable, and we actually were able to predict them better than the other teams, so we won the shared task. So that's all. I'm now stopping the sharing, the screen sharing. So I will now stop the recording briefly.